So the first one is going to be functions that are monadic or those with a single argument. There's two common reasons within our computer programs where we want to have a function with a single parameter. The first reason might be to ask a question about an object. You might think like, is the object valid? Is its number within some acceptable, range, etc. There's a number of different scenarios where we're very much interested in the current state of a particular object within our program. So just passing that single object to the function and returning a result is, a very common reason to employ a monadic function. The second is going to be perform an operation on an object. So essentially, we'll input a object into a function, some computation will ensue, and then something else is kind of what will become of that object, and it would be returned to the person who called that. When we're dealing with monadic functions, the function name and argument should follow a verb-noun pair form. Dyadic functions. These are going to be somewhat more difficult to understand than monadic functions from a reader's perspective. These are going to be very sensible when parameters have natural cohesion and or natural ordering. It's going to take time to learn ordering conventions, and cognitive load is increased, which is one of the reasons why we say, it's 1 or 0 is the best, 2 is not uncommon, but you do pay for it. So we really do want to convert these into monads when possible. Otherwise, we want to be very descriptive about kind of how to use them. For instance, you can use keyword form of a function name to encode the names of the parameters into a function. I can't tell you how many times I've gone through writing simple assert statements within my code, and I'm always forgetting whether or not what the ordering of the expected or actual values are to be passed to that function. So if you were to write something instead like exert expected equals actual, there's no question about what the first argument is going to be and what the second argument is going to be. I'm not going to have to look up any documentation. I'm not going to get nervous and go, oh, did I actually call that function right? It's so much more self-describing in this scenario, and it's very clear what's being compared to what and what the outcome may communicate. Anything that forces one to look at the function signature should really be avoided. So again, don't feel bad about using descriptive names, even if it means they have to be a little bit longer than perhaps you might like. Triads. So these are significantly more difficult to understand than dyadic functions, again, because there's just more going on, more input. Obviously, if we're inputting this into a function, it's somehow being used in the computation to generate whatever output it might be. Question here, and this goes back to the dyad functions, is have you ever got the ordering of the arguments wrong? I have many times. You might likely have too. So you just make a habit of checking the documentation, checking the prompts that your IDE might produce to remind you of what the correct ordering actually is. So only use these after careful consideration. And what we'll see here as we move through the course, and as you may already be familiar with, there's different ways to group data and kind of operations that can be invoked on that data together, encapsulated it up, kind of bundled it up into a type, as we'll see. So just looking at this example, we have this function. I mean, it really doesn't matter what's really happening. It's not our concern, but we're assuming some sort of circle is going to be constructed. We have a function called make circle. It has 2 arguments that kind of communicate its placement, x and y, and then an additional argument, or in this case, parameter, radius, which would communicate the size of the shape being constructed. If you look at that, having 3 doubles is going to be a little bit complicated to make sure you have the correct ordering. I can kind of see the cohesive grouping and that, okay, x and y probably go together, but do they come before or after radius? What is, how do you order this? And this is something that you'd probably end up relying on the IDE's little reminder prompts to tell you how this function's to be used. However, if we were to do something like following and group up, say, the components X and Y into some sort of type called a point, it becomes very clear, or at least clearer, how make circle is supposed to be used. In this case, we have a point, which is going to be the center of the circle, so where we're going to draw out from of a specified radius. Notice here in the first example, what X and Y are is not very clear. Was it like the top left portion of the circle and we, kind of stretch it from that point? But the second example shows that it's the radius and we're moving out from that to construct a circle directly around that point. So again, there's, when you start having more than two arguments, do start thinking about how perhaps, the parameters could be better organized, and whether or not maybe there should be a different sort of grouping of the data within your program to make it in a more informative way to the user. Because X and Y, it's like, what is that? Okay, it's being used as a point here. Okay, that helps a little bit. How's the point being used? Oh, as a center point. So another kind of attribute of a good function is to avoid flag parameters. Passing a Boolean into a function suggests that the function probably does more than one thing. There's probably some area where you're going, hey, if the flag's set to true, I'm doing one thing. If the flag's set to false, I'm doing another. In this situation, just split it into two functions. Because again, a function should only do one thing, and it should do that one thing well. If you start wanting to say test functions that have flag parameters, that's, you now have two different scenarios to consider. Whereas if you had had split this into two functions, you'd essentially be testing them independently one another, which is advisable. A function should have no side effects. So functions should do only one thing. They should be predictable, and the name should be implying what's going to happen. So don't include code within your functions that essentially change the state of maybe an object that's passed to it or other components of the program unexpectedly. So if I read like, print value to file or something, I'd expect the file to contain whatever the argument is passed to the function. We shouldn't be going in and like maybe opening the file at this point or doing other things that should have been done before this operation took place. We probably shouldn't be closing the file after we've written to it because again, that name's not descriptive, describing it. We're simply writing to the file. So that's what our expectations are. We're writing and we're not doing anything else. That's the one thing that we're doing. Another one, do not repeat yourself. You've probably heard this before. If not, you're hearing it now. So when you repeat yourself, you make more changes if an algorithm needs to be modified. So let's say you write a sequence of statements to do one sort of operation. And then as you're going through your code, you're realizing that, hey, I need to a similar or the exact identical sequences in this point. So you go up, you copy and paste what you had before, paste it in at this new point in the program, and continue on your merry way. Notice here that if you have this code now in two places, and then you find out that maybe you didn't implement it right the first time, there are now going to be multiple areas, in this case two, where you're actually going to have to go back and change that algorithm. And it's very likely that you could correct this in one place where that error is presenting, forgetting that you had reused this identical code in some other place in your program. So repeating code in this manner is definitely going to increase the chance for an error to occur. And it's also going to create more work for yourself because A, you're going to have to remember, okay, where was the snippet used? And then B, what are the changes that I might need to make to introduce some sort of improvement or correct some sort of issue? So you can eliminate this duplicate code. It's very easy. Just we're going to go ahead and take it, put it in a function, give it a name, and then just invoke that function whenever it is that we need that kind of block executed. So functions, we'll get into this in the next video, but this is where we'll start talking about the composition of a function in the C++ language.